Okay, welcome to 3.4, Zeros of Polynomial Functions. So this section we're going to take a deeper look at finding all of the zeros of a polynomial function. So when we think of the zeros, we can think of the x-intercepts of the graph. Okay, the x-intercepts of the graph. Sometimes they're called the zeros, sometimes they're called the roots. Sometimes they're called the x-intercepts. So let's take a look at some theorems here. So the fundamental theorem of algebra states that if p of x is a polynomial of degree of n is greater than or equal to 1 with complex coefficients, then when you set the polynomial equal to 0, it has at least one complex root. Okay? And we'll be able to find that by finding that it's going to have exactly n roots when it has an nth degree, right? So the linear factorization theorem is just going to be stating that you'll be able to write it out as x minus your root, or x minus your zeros, or x minus your x-intercepts. Those all mean the same, x minus the zeros, or x minus your x-intercepts. Okay, so you'll be able to write these all out using the linear factorization theorem. Okay, so let's start off by taking a look at some zeros when it is x to the first, linear. When it is x squared, which is a quadratic. When it is x cubed, a cubic. And when it is x to the fourth, a quartic. Okay, so we know that when it's x to the first, 1, we should get one answer. When it's x squared, we'll get 2 answers. X cubed, 3 answers, and x to the fourth, 4 answers. So all we're going to do here is we're going to set this equal to 0 and solve for x. So therefore, this linear polynomial has an x-intercept at x equals 2. This one here, if we set this equal to 0 and then we factor it, we say what multiplies to 9 and adds up to -6. That's x minus 3 and x minus 3. We'll set it equal to 0. That's really x minus 3 squared, which equals 0. So we're going to get x equals 3. And this is actually going to give us a multiplicity of 2 because it comes up twice. And when it comes up twice, that actually is telling us that at that 0, at x equals 3, 1, 2, 3, it's going to have the vertex here, or it's going to touch and turn. Okay, so this is a parabola. Sorry, my terrible parabola shape. At 3, it touched and turned because it has 2 of them, a multiplicity of 2. Cubic, we're going to get 2 answers. So, sorry, going back to this one, x equals 3. This is 2 answers because it has a multiplicity of 2, x squared. Okay, coming back over to here, a cubic, we can factor out an x here, and then we'll have an x squared plus 4 left over. We set that equal to 0. We make our t-chart here. We get an x equals 0. So it'll cross at x equals 0 there, which also means that's the y-intercept. Then we'll take x squared plus 4. We'll set that equal to 0. We get x squared equals -4. Take the square root of both sides here. And we get plus and minus. The square root of 4 is 2. The square root of a negative number is I. So that is 2 answers. And then our third answer. Here we can see this is a quartic, so we should get 4 answers. So here we should actually be able to see that we can use substitution here. I can write this as x squared squared. I'm going to write that equals 0. And then I'm going to let a equal x squared here. So I can write this as a squared minus 1 is 0. I can see I can use difference of 2 squares, so a plus 1 times a minus 1. Now I'm going to plug my x squared back in here because we want to know what x is, not a. So I get x squared plus 1. I get x squared minus 1. I set them both equal to 0. Here I get an x squared plus 1 equals 0, which will give me x squared equals a negative 1. Taking the square root of both sides, I get x equals plus or minus I. That's two answers because it's plus I and negative I. Here I get x squared minus 1 is 0, or x squared equals 1. Take the square root of both sides and I get another two answers, plus and minus 1. That means that this quartic polynomial will cross at positive 1 and negative 1. So all of these we factored and we are able to find the zeros. Okay? So moving on here, this is when we're going to use the rational zero test when you cannot factor it. And what we're going to do here is we're going to find the possible rational roots, or the possible rational zeros. Okay, so we're going to find that by finding the factors of the constant term over the factors of the leading coefficient. Or when it's in standard form, we're going to find the factors of the last number, I'm just going to write it like that, over the factors of the first number. And this is when it's in standard form. So we remember that standard form is always from the highest degree, the highest exponent, to the lowest exponent. Okay? So let's take a look here and just find the possible rational roots, meaning this is what it could be. Okay? It could be any of these. So let's take a look here. We're going to list all the possible rational roots, or PRR. So the possible rational roots, this is what it could be. For this one, I'm going to list the factors of negative 6 over the factors of, because negative 6 is my constant, over the factors of my leading coefficient, which is a 1. So the factors of negative 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Don't forget the plus or minus. Over the factors of 1, which are just plus or minus 1. So when we divide all of those, we just get plus or minus 1, 2, 3, and 6. So this is what it could be. So right now we're just listing the possible rational roots. And then in the next slide, we'll find all of the actual roots by using synthetic division. Okay, here we list the possible rational roots. We list the factors of 4, our constant, over the factors of our leading coefficient, 3. So for the numerator, we get plus or minus 1, 2, and 4. And in the denominator, we get 1 and 3. Don't forget the plus and minus. Now we're going to divide each one by 1. So we get plus or minus 1, 2, and 4. So I did 1 over 1, 2 over 1, 4 over 1. Now I have to divide each one by 3. So I go 1 over 3 is 1/3. 2 over 3 is 2/3. And 4 over 3 is 4/3. Okay, so these are all of the possible rational roots here. This one is a little bit longer. You still list all the factors of negative 12 over the factors of negative 10. And you'll end up getting a lot. So we have, for the numerator, plus or minus 1. Just know that this is all going to be plus or minus. So I'll just put this in parentheses. 2, 3, 4, 6, and 12, all over plus or minus the factors of negative 10 are 1, 2, 5, and 10, and then I have to divide all of these out. So I'll divide by 1 for all of them, so these are all going to be plus or minus. So I get 1, 2, 3, 4, 6, 12. Now I have to divide each one by 2. 2 over 2 is 1, we already have. 2 over 5 we need. Starting with, let me erase that. I should do it for the 1 first. So 1 over 1, So now I have to divide each one by 2. So 1 over 2 is a half. Okay, then I have to do 1 over 5. Then I have to do 1 over 10. There we go. Oops, that's a 10. Now I'm going to do it for the 2. 2 over 2 we already had, because that's a 1. 2 over 5. 2 over 10 is already 1/5 we had. Now I move to the 3. 3 over 1 we did. 3 over 2. Okay. 3 over 5. 3 over 10. Then we move to the 4. 4 over 2 is a 2 we had. 4 over 5. And 4 over 10. And then we do it for 6. 6 over 2 is a 3 we already had. 6 over 5. And 6 over 10. You can reduce these if you would like take a 2 out from here. This is a 2 over 5, which we actually already had that up here. 6 over 10, we could take a 2 out, so we have a 3 over 5. Did we have that one? Yes, we had that one, so we don't need to write that again. Okay, and then we do it for 12. 12 over 1 we did. 12 over 2 is a 6 we had. 12 over 5. And 12 over 10, that reduces, take out a 2, a 6 over 5. We had that. So this is all the possible rational roots. Okay, moving on here. Alrighty, so here we go. We're going to take a look at now finding the zeros of the polynomial functions. So the first thing you're going to do is you're going to list the possible rational roots, just like we did before. So here we go, the possible rational roots. It could be plus the factors of 3, so plus or minus 1, plus or minus 3, over the factors of 2, plus or minus 1 and plus or minus 2. So I'm now going to divide. 1 over 1 is 1, 1 over 2 is a half, move to the 3, 3 over 1 is 3, and 3 over 2. So this is what it could be. So now what we're going to do is we're going to test to see which one will actually work. So you could start with a 1. I'm going to start with the 1 and I'm going to use synthetic division. I write all of my coefficients, 2, 3, negative 8, and 3. Make sure you go nice and slow for these so you know that you don't make a small algebra mistake when you're doing these. We bring down the 2, we multiply. 1 times 2 is 2. We add, we get 5, multiply 1 times 5, add, we get a negative 3, multiply, we get a negative 3, add, and we get a 0. Excellent. So that means this 1 is a 0. We have x equals 1. It also means that we have x minus 1 is going to be a linear factor because it's always x minus the root. And here we know that this is going to be our constant, our linear, and our quadratic term. So x minus 1 times 2x squared plus 5x minus 3 is what this cubic factors out to be. So if we set this equal to 0 and we actually solve this, we can look to see, okay, I already have it for the x minus 1. We already know that's an x equals 1 from this. And now here we can look to see if this could be factored. We go a times c, 2 times negative 3 is a negative 6. We say, is there anything that multiplies to negative 6 and adds up to a 5? We think about what that would be, a 6 and a negative 1. So I'm going to go ahead and replace my 5x with a 6x minus x, because that's 5x, and then a minus 3. Factoring by grouping here, I'm going to take out a 2x. I'm left with an x plus 3. I know I have to have an x plus 3 left here, so I'm going to take out a negative 1. Okay, and then these both had in common an x plus 3, so I'm going to take that out. And then I'll have a 2x minus 1 left. And there we go. We were able to factor that. So, making a t-chart here, we get x is negative 3, And here we get 2x equals 1, or x equals 1/2. We knew we were going to get 3 solutions here. And the reason why we knew we were going to get 3 solutions is because of this x cubed. So we got 3 answers, or x equals 1, x equals -3, and x equals 1/2. Those are the zeros of your graph, or where it's going to cross your x-axis. Okay, moving on here. Let's see. So we will have a fourth root, one that's to the fourth, or quartic, and a quintic, x to the fifth. So let's take a look here. We start again with our possible rational roots. These take a little bit of time, which is why I'm also making a video for this one. But listing the possible rational roots for 21, we get plus or minus 1, 3, 7, 21, all over our factors of 6, which is 1, 2, 3, 6. Multiplying or dividing those out, we get plus or minus 1, 1/2. I'm dividing each one. 1/3, 1/6. So this has quite a few. Dividing your 3, we have 3. We have 3 over 2. We have 3 over 3, which is a 1 we had. 3 over 6 is a 1/2 we had. Moving to the 7. 7 over 1. 7 over 2. Okay, 7 over 3. 7 over 6. And then the 21. 21 over 1. 21 over 2. 21 over 3. And 21 over 6. So quite a few here. Okay, so this is what it could be. So now we have to go ahead and test the ones that we think it would be. Alright, so let's give it a shot here. We could start with 1. Don't think that it will always work for your 1, but I'm going to give that one a try again. Notice here that we're starting with a quartic. So when I do synthetic division, this is important here. When I do synthetic division for the first time, I'm going to end with a cubic, which means I'm going to have to use synthetic division again in order to end with a quadratic. Okay, so here we go. Here we have a 6. Make sure no terms are missing. -5, -65, 85, and -21. Oops, not very straight of a line, but that's okay. Okay, so here we go. We're going to multiply this out. 6 times 1 is 6. Adding these, we get a 1. Multiply, add. Keep going all the way to the end. Multiply, -64. Add, we get a 21. Multiply and add. Awesome. There we go. That means that x minus 1 is a linear factor because we got x equals 1. And we also know this is my constant. This is going to be my linear term, my quadratic term, and my cubic term. So x minus 1 times all of this, 6x cubed plus x squared minus 64x plus 21. That is starting our factoring of this quartic. So now we need to factor this cubic, and notice we still have a 6 and a 21 to end with. Our constant is 21, and our leading coefficient is 6. So again, we're using these as our possible rational roots. Keep in mind that sometimes you will have repeated zeros. So the 1 can work again, but it won't always work. Okay? So I'm going to try a different number. I'm going to try 3. See if that will work. I'm using these numbers now. Do not go back to the same quartic numbers. Then you're just going to end up with a cubic again. You're using these as your coefficients. 6, 1, negative 64, 21. 6, 1, negative 64, and 21. You're using those numbers. Okay, so here we go. Bring down the 6. Sorry. 256, bell ringing. All right, multiplying that out, we get an 18. Add, we get 19. Multiply that out, 3 times 19, 57. Okay, add those, we get a negative 7 here. Multiply, we get a negative 21. Add, and there we go. Okay, so that means now I have x minus 1 from this one here. I have x equals 3, which means I have a linear factor of x minus 3. Now I have all of this, my constant, my linear, my quadratic. So now I have a 6x squared plus 19x minus 7. That is the original quartic that we had. Okay, if I scroll up a little bit. This right here is factored to be this right here. So now we have our quadratic, and we can find the last 2 zeros because we know we need to have 4 zeros. So since this cannot be factored, we're going to plug it into the quadratic formula, and here we go. X equals negative b, so negative 19, plus or minus the square root of b squared. 19 squared, I believe that's 361. I should probably check that. 19 squared, 361, yes. Okay, and then we have minus 4 times 6 times negative 7. That is, let me check that just so I'm not making any mistakes. 4, 6, and 7, 168. So that's a plus 168 though, because we had a negative and a negative. So plus 168 all over my 2a. So 2 times 6 is 12. Okay, let's simplify this a bit more. Negative 19 plus or minus the square root of 361 plus 168. That's a 529 all over 12. And that will be it. This is 2 answers here, along with our x equals 1 and our x equals 3, for a total of 4 answers. Okay, let's get to this 5th power, or a quintic, shall we? All right, here we go. This one will take a little bit of time, so follow along with me here. Let's start out with our possible rational roots. So luckily, the leading coefficient is 1, so we won't have too many possible rational roots here. We're going to get plus or minus, the factors of 8 are 1, 2, 4, and 8. Okay, so that's what we have to work with here. Okay, we have 2, 4, 6, 8 different possibilities, not too many. So let's give it a try and start with a 1. And notice here, this is important. There is no x to the 4th, so I need to put in a 0 for that placeholder. I have a 1, 0, 1, 2, negative 12, and 8. I'm putting in a 0 for that placeholder of x to the 4th because there's no x to the 4th. Okay, so here we go. We're going to bring down that 1. We know we're going to end up with a quartic at the end of our synthetic division because we ended up with a quintic, x to the 5th. Okay, so 1, multiply, add these two, you get a 1, multiply, add, multiply, add, multiply, add, multiply, and there we go. Excellent. Okay, that means to start us off, we have an x minus 1 as a linear factor. because we had x equals 1 worked out. Then this is going to be my constant, linear, quadratic, cubic, and quartic. Okay, so that means x minus 1 times x to the 4th plus x to the 3rd plus 2x squared plus 4 to the x, or plus 4x minus 8 is factored. When we multiply this out, we're going to get back to this x to the 5th, all that quintic. Okay, so now we need to do this again. And remember we said earlier that sometimes it will end up where we're going to get we'll get a multiplicity of a 0. So I'm going to try 1 again and see what happens. So using the numbers that I ended with for my synthetic division, 1, 1, 2, 4, and -8. Here we go. Because I need to get this down to a quadratic. Right now it's a quartic. Bring down the 1. We multiply. 1 times 1 is a 1. We add, we get a 2. Multiply, we get a 2. Add is a 4. Another 4. 8, 8, and 0. Okay. That's a weird smiley face, but that's okay. So, here's what this means. We have another 1, which means I have x minus 1 times x minus 1, or you can write x minus 1 squared, times my constant, linear, quadratic, and cubic. Okay. So this is x cubed plus 2x squared plus 4x plus 8. Okay, we need to do it one more time because we need to get it down to a quadratic. Okay, so let's try -2. This is already a long enough video, so I'm going to use the one that worked out. Good thing I did this problem before I made the video, right? I'm using these coefficients here. I have 1, 2, 4, and 8. Bringing down the 1. I multiply, get a -2. Add, you get a 0. Multiply, add, multiply, and add. Okay. That means now I have x minus 1 times x minus 1 times x plus 2 times what we just got here. My constant linear is nothing, and then quadratic. So this came out to be x squared plus 4. So here is x squared plus 4, and then we're just about done. We know we're going to end up with 5 answers. We already had all 3 of these first ones. So this one will give me an x squared equals -4. I take the square root. This will give me 2 answers of plus or minus 2i. So here's 2 answers. My other answer here was a -2, 1, and a 1. For a total of 5 answers. That was a good one. All right. Moving on. Actually, I'm going to stop the video and then start again for the next part. All right. Thanks for listening, and make sure you listen to the second part of this.